Watch what happens when the lights turn on.
So I've been doing a bunch of different experiments like this, but I'm just going to share a couple here in this video because otherwise it would just be way too long. What you're looking at here is something I was kind of excited about, but it doesn't seem to be delivering to my expectations.
There's a copper disc under there on this cantilever. One end is on the scale plate. So although not much seems to be happening here, if you can stick through towards the end of the video, you'll see what I do that gets a much stronger effect. These are 3 pairs of mirrors that are both facing, each pair is facing each other. The mirrors, reflective sides are inside facing each other with a string of LED lights going around, so all the light is contained, not all of it, but a lot of it is contained between the two mirrors. So what I've noticed is this. I thought this would have a lot more effect because of the intensity of the light being trapped in here. But it's looking like there's something about direction of the photons. Because if I apply a low-powered line laser here, see it's sort of staying there about 60 milligrams. Now if I put this line laser across the top here, so it's shining down over top of the mass, watch what happens to the weight. It seems as though gravity is kind of being, almost like it's being directed off of a roof made of photons. Like it's sliding off this plane that's caused by the laser light, the photons. What happens to the weight? Now when I turn the line laser off, now the little copper mass is reconnecting to all the other masses in the universe at the speed of light through the vacuum. Kind of like same idea as Mach's principle. Let's see if I can set my camera down here. There we go. So it's going back up to 50 now, where it was when I started. Let me try the laser again. So this is kind of an unexpected result here, although it makes intuitive sense. So I just got the laser over top here, down about 45 degrees, on a 45-degree angle, coming down over top of the cantilever. This is a 5 milliwatt laser. It's not like it's high power. Change the angle here a bit, make it a bit higher. Actually, that looks like a 45-degree angle right there. Now if I go a bit steeper, say like 60 degrees. Oh, come on. It's almost like gravity is like rain that's falling from the sky, and it's coming down on all objects from space, but the laser light deflects it partially, partially shielding the objects underneath the laser beam by pushing these vacuum particles, whatever they are, slightly away, deflecting them. There we go. Come on. Down you go. Down you go. Anyways, that gets tiring. There it goes back up again. Here's my setup. If you find this interesting and helpful and you want to do these experiments, or you have ideas on how to improve them, or you want to collaborate, send me an email. My email address will be in the description. Thanks. I think that's pretty convincing. That the photons couple with these particles or in space, and then it almost seems like they push them away or deflect gravity. There's theories about push gravity, that it's like comes from the ether and it pushes in on all objects, on all mass. Let's just see if that goes back up to 50. So yeah, it seems like the direction of the photons is important, because in here all the light is going towards the center, kind of in all different directions here, instead of being going in one direction across. Can I call that 50? I think I can call that 50. Yeah, close enough. So I just turned the LED lights off, the white lights. And so it did go up a few more here. Now it's up to 55 milligrams. And the reason it's at this is because it is kind of hard to tear it to zero, because there is the environment is constantly changing. The gravitational environment, I mean, it's always fluctuating, and it causes, in this type of setup here, it won't move around so much if the weight is directly on the plate, on the balance plate, but in this case, it's much more pronounced. Which is an important, it's an important thing to accommodate when doing these kinds of experiments.